In this video, I'll be explaining type aliases. Type aliases allow you to rename existing types. As just mentioned, type aliases allow you to give a new name to an existing type. Type aliases are just basic text substitution that must follow the syntax of a type signature. Type aliases simplify complicated type signatures, which makes code easier to read and to write. When using type aliases, the underlying types are checked by the compiler, but unlike new types, the alias is still the same as the original type. This means you can create multiple aliases on a single type and utilize them in your program, but the compiler will only see the underlying type. We'll have an example of this shortly. Here's the syntax for creating a type alias. We use the type keyword along with the alias we wish to use, and then an equal sign, and then the actual underlying type. So this will be the alias, and this will be the concrete type. Here's a few examples. Here we have a type, and we're naming it contact name, and the underlying type is a string. So whenever we use contact name in our program, we'll get a string replaced. Our second type is one named Miles, and we're setting it to be an unsigned 64-bit integer. We're also creating a centimeters type and setting it to an unsigned 64-bit integer as well. Both miles and centimeters are unsigned 64-bit integers. Therefore, they can interact freely with each other. This is probably not desired, because you can have both of these as function parameters and the code will look fine, but you can accidentally use centimeters instead of miles, because both are unsigned 64-bit integers. Due to the fact that type aliases are just the underlying type, using a type alias for a single type takes a little bit of care. I try to limit these to a single module in order to reduce the chance of mixing up some data. If you want to ensure that no mix-up can occur, then you'll want to use a new type. On the bottom here, we create a type alias named callbacks. We set the type to be a hash map that's keyed on the string, and each value is a box containing a function that takes two parameters and returns an I32. This example here at the bottom is a more appropriate use of type aliases. The chances of mixing up this type with something else is probably pretty low, and if you do mix it up, then you're likely to get a compiler error. So the rule of thumb with type aliases is the longer the type signature, the more appropriate the type aliases become. Let's take a look at type aliases in a small program. Here we have a structure named contact with a name and phone number. Both of these types are strings. We then have two type aliases. One is named contact name, and the other one is contact index. The contact name is a string type, and the contact index is a hash map that's keyed on the contact name, which is here, which is a string, and the value is a contact, which is up here. We have a function named addContact, and it takes a contact index, which is a mutable contact index. So instead of writing out hash map contact name contact within our function signature, we can just put contact index because we defined it as a type alias. We also accept a contact as a function parameter, which is just the contact structure. We then do index.insert, so we're using the insert function on the hash map, which is set up here. We then take the contact's phone number, turn it into an own string, and add that to our hash map. And then we have the contact information, which will be keyed on the phone number. You may have noticed that our hash map is keyed on the contact name. However, in our function, we took the contact's phone number and used it as the key. You'll note that both of these fields are strings, and we accidentally used the phone number instead of the contact name when we inserted the contact into the hash map. This is one of the pitfalls of using type aliases with a single type. You can accidentally end up with little bugs like this and not notice it because the compiler only sees a string in that location instead of a new type. If instead we created a new type instead of a type alias, then this would result in a compiler error. We can also use generics and lifetimes when we're creating type aliases. On this first type alias, we have a lifetime tick A, and we're creating an alias to a vector which has a tick A lifetime for stir. In our second example, we're creating a type alias named generic things, and it has a generic parameter t. This generic things is being aliased to a vector, which contains things, and the thing has a generic t. To recap, type aliases are a way to declare another name for a type. They can have generic parameters and lifetime annotations. Prefer to use type aliases on longer types. This will help you avoid bugs, and it'll make your code clearer and easier to read. Smaller types should be limited to a single module. That way you don't accidentally mix up types. If you need the compiler's help for checking types, use new types. That way you get compiler error if you use it incorrectly.